So now we're going to see if we can apply what we just learned about elasticity and how to measure it by cooking a steak. We're then going to measure the elasticity of a raw piece of steak and a piece of steak that is cooked to about well or medium well, and we're going to see how the elasticity of the steak changes as the steak cooks. We have a steak here, and in order to do this scientifically, we have cut out little pieces of steak, and they're all the same dimensions. So they're 4 centimeters by 4 centimeters. And we're going to apply a weight to the steaks before and after they're cooked, and we're going to see how much they compress. And then we're going to use the equation of the week and see if we can calculate the elasticity. Okay, so here's our little setup for how to measure elasticity. Very simple. You can even set this up in your own kitchen. So we have a little plastic plate that we're going to place on top of the piece of food, and then we have a ruler, and then we have a weight. And here I'm showing you a 200-gram weight that we're just going to place on top of the steak. And as you can see, the initial measurement for this is 30 millimeters. And it's a little bit hard to see, but then as we apply the weight, the 200-gram weight, the measurement goes down to 26 millimeters. So there is a compression of 4 millimeters. So now we can just take these numbers and plug them into the equation of the week and see what we get for elasticity. So we know that elasticity is stress over strain, and stress is the force over the area, and we already know what the area is because I told you that each side of the steak is 4 centimeters by 4 centimeters, so that's 16 centimeters squared. And the force is the mass times the gravitational constant. So the mass is 200 grams, that's 0.2 kilograms, times 10 meters per second squared. Okay, and for our strain, we have the delta L, the difference that we got, which was 4 millimeters, over the initial height. So that is 4 millimeters over 30 millimeters. So if we now just plug all of this in, this is 2 newtons over 16 centimeters squared, and 16 centimeters squared is 0.0016 meters squared. So we need to make sure we go back to the SI units. And then we divide this with 4 over 30 millimeters. And so this turns out to be 9,400 newtons per meter squared. So this is our elastic modulus for a raw steak. Now let's go and do this for a cooked steak, which Daniel has cooked for us. So here we now have a cooked piece of steak, and it's been cooked to about medium well. And the force is still the same. It's 200 grams times the gravitational constant, so it's 2 newtons. And the area is the same. It's 4 centimeters times 4 centimeters. And as we apply the weight, you can see how the steak has compressed to 28 millimeters. So there's a change there's a compression of 2 millimeters. So about half as much as you saw in the raw steak. So now let's plug this into the equation. And so this turns out to be 18,700 newtons per meter squared. So this is about twice the elastic modulus as we saw for the raw steak. So the steak has actually become stiffer as we cooked the steak.